What's up guys? Today I want to show you how to install an interesting project called Minikube into your laptop so that you can set up a local Kubernetes cluster right away. In case you are new to Kubernetes, Kubernetes is a very powerful cloud environment deployment and management system that allows you to create or maintain a large-scale cloud cluster in a very efficient manner in terms of computing resources such as memory or CPU. And I guess it could be one of the reasons why there are so many leading technology companies are trying to use Kubernetes to manage their cloud development environment. This is also why there are so many people want to learn Kubernetes, and I think learning through experience is the key. This is where exactly Minikube can help you. By simulating a virtual instances for a local Kubernetes cluster, it will save you a lot of effort to configure your environment to work with standard cloud platforms such as Google Cloud Engine or AWS. So enough talk. Let me show you how to get all this done and start to deploy your first web applications into your personal Kubernetes cluster right away. Alright, so the first thing we want to do is to figure out which command we want to use to install Minikube into our laptop. And all of this information is in the Get Started section of the documentation. In case you can't find this documentation, just type Minikube in your favorite search engine. And then you're going to choose your own operating system. Like me, I'm just going to choose the Mac OS, copy this command here, turn my terminal, paste it, and hit enter. And now Homebrew is going to install the Minikube for me. It's downloading something. Okay, now it's done, and we can start to play around with it. The first thing we can do is to see which version we're using. Another useful command called Minikube status, which tells you the current state of your Kubernetes cluster. Now it tells you there's no local cluster, which is expected because we haven't started up anything. So in order to fix that, I'm just gonna start to follow its instruction by running Minikube start. Now it's trying to start a cluster named Minikube by default, and also it's going to create a virtual instance Minikube. Besides, we'll also install some necessary components needed by Kubernetes, such as Docker, container runtime engine. Of course, it supports various other container runtime engine like Containerd or Cryo, but that needs a little bit more configuration if you want to use that with Minikube. Now it's done. If you run Minikube node, you will see that it's just create a node for you, and this is where exactly you want to deploy your application in the form of a pod. Here it's kind of a new concept, pod in Kubernetes world, and when the Kubernetes move your application from here there, from its pod, from its node to the other machine, it always moves the pod as small as a unit, and everything inside the pod could be one container or multiple containers which share some storage network, stuff like that. So if you run this, it will show you every pod that's been running there, and you can also do -OY to kind of show more information. You can see it also marked which nodes has this pod been deployed to. Currently you only have one node, so every one of them shows Minikube here. Okay, if you run a couple more times, you can see the status of this is changing. It takes a little bit time for it to run. Let's wait a little bit time for it to start up. Okay, you can see more are trying to be in a ready state. Okay, now it's all up, and now I think it's a perfect time to introduce another fancy feature of Minikube called Minikube dashboard. So this is an open source project called Kubernetes dashboard, which will visualize all the information you're having inside your Kubernetes cluster. Minikube actually install that automatically for you, so you don't have to do that yourself. Looking at the left hand side, it shows you various resources that are supported by Kubernetes, including the nodes and the pods we talk about. However, if we want to know more about other type of resources listed here, feel free to go ahead checking that out in Kubernetes documentation. This whole Kubernetes dashboard is very explanatory, so you just need to clicking into each object to get more detailed information. For example, regarding to this single node we're having in this cluster, besides metadata, it will also show you the CPU memory usage as well as the pods that are being deployed into these nodes. Of course, clicking into each pod, you will again get more detailed information regarding to that single pod. So if you are doing the same thing on your laptop following me, feel free to play around with this Kubernetes dashboard. Some of this resource type, when you click it, like jobs or ingress is here, it doesn't show you too much things which are empty. That's actually as expected because we haven't deployed too much things into this cluster. It's pretty new. So now let's go back and start to deploy our first HTTP application into this cluster and see what kind of change it will bring to us. It's just several file, and I'm using Python just because it provides some very cool library to do that very surely. But if you have other languages that you're more comfortable with, just feel free to use that. Now, see, what I do is just simply create a socket server, let it serve forever at the port 8000, right? And all it does after the received request is to render a index HTML like this. So let me just quickly host this server in my laptop to show you what it looks like, and try to hit the local host at the port 8000, and it works. So if I go back terminal, you will see a log here indicating someone hits the server. I'm going to kill it, and we're going to lose this server as expected. Now the question comes to, how do we deploy our simple HTTP server to the Kubernetes? And the answer is containerization. In the cloud environment, Kubernetes doesn't know what kind of dependencies you need as well as your application code. So we need to package all these necessary dependencies together ourselves as a container image. And we are using Docker here. So in order to do that, you need to create a file called a Docker file. And here, since it's pretty simple in our example here, we have a very short Docker file, and you can see that it's trying to pull the base image of Ubuntu and trying to install mainly the Python as dependency. The entry point key here is being used to show how does the container start itself, which here apparently is using the exactly same command we're using to test locally, right? After you have the Docker file ready, you just need to run docker build, give it a name, HT web app, and then let it to build using the current directory. Now it's building, and you can see it's trying to put in the Ubuntu base image, which might take some time. And you can see also it's trying to put in something regarding to Python, right? And now it's done. Now you have the image ready. Now the next question is that how do we deploy that image to the Kubernetes cluster, right? Actually, Kubernetes provides a way to just use very simple configuration file in the form of a YAML to convey our information regarding to our deployment requirements. Let me show you what it looks like. This is a file that are created for this deployment, and I'm telling Kubernetes to deploy a resource type called deployment with such name and some metadata. What is more important is that I tell Kubernetes that I want 3 pods as replicas, as well as the actual template it should use to create those pods. Inside this template, one important specification here is the image name that I want to use to start up the container, which exactly the image I just built. So now what I'm going to do is run minikube kubectl -- apply this file. Simple as this. Now you can see it tells me that this deployment is being created. So I want to know what's going on after I run with this, right? I can do several things such as get pods. You can see that now Kubernetes is trying to spawn up 3 different paths in our cluster, and I can switch this path to all to CMOL, and it will show me that as asked, Kubernetes create a deployment named HTTP server, and these 3 paths are controlled by the replica set generated by this deployment that we ask Kubernetes to create. So you can see that everything is designed in a loosely coupled way so that we don't tell exactly how does Kubernetes does things. We tell them some important information as we described in the configuration file, and the Kubernetes will calculate the discrepancy between the required state and the current cluster state, and it will try its best to fulfill our requirement. And you can even run it a couple of times to see when your application will be ready. But now we notice that there's something wrong happening in the status called the image pullback off. What we can do is to grab some more information. kubectl, we can describe each part, and you will see that it shows you some information in the events, basically saying that it failed to pull image with the name that we ask from some repository, which is interesting because when I run docker image ls, it shows that actually we already got the image built, right? Then why doesn't Kubernetes find out the actual image? The answer is pretty simple actually, because we just built the image locally, it's in our laptop, but by default the Kubernetes system will pull some image from the configure repository of the container runtime engine, which is Docker in our use case. So now what we need to do is to actually push our Docker image to the remote Docker Hub repository so that the Kubernetes can find that. Let us try to do that. Firstly, we need to have a Docker Hub account. We go to the dockerhub.com and register account if you haven't. I already have account. Let me just input the credential. Alright, so click repository here. There's currently no repository in my Docker Hub namespace. Remember, cloud meaning is my account name. It's also the namespace of my Docker Hub repositories. And this is going to be very useful for me to be able to find my Docker Hub repository. So now I'm going to create a repository. I'm going to give it a name. I'm just call it my web app. And I'll make it public. If you make it private, you can also do that. However, that needs more configuration to Kubernetes cluster so that it can store your credentials to access your private repository. For this demo, I'm going to just make it simple. Now hitting create. Let me go back. You can see I have a repository over here, right? But currently there's nothing here. It shows lots of pushes, never. Makes sense. And it actually tells me that in order to push an image, I just need to run this command. Now let's go back to terminal. We need docker login also. Dash username. And type my credentials again. Login succeeded. And I'm going to paste this one. First, I think I should use the latest tag, but it tells me the image doesn't exist. That's just because if I alert my image is actually called my web app latest. I'm going to need to tag my web app latest to this new name just to match my repository. Alright, I'm going to run it again. You can see it's pushing. Okay, now it's done. Let's go back to the web interface. Refresh that. And you will see that it shows lots of pushes a few seconds ago. and the tag is the latest. All right, and then we can check a look at what's going on in my cluster. It still has problem accessing that, but to make it trying to put image again, I'm gonna delete pods. When I use -L, it would delete all pods with this label attached. This will force it to trying to re-put the image. Something still doesn't go well. We can check what's going on. So usually when this happens, we can try to get the deploy configuration, see if anything is wrong. We can use -O YAML. Remember to put the -- here if you want to use dash later on. All right, so it shows a lot of information. Okay, you can see since we just retagged the image to a different image name, so we gotta edit this. What we can do here is change get to edit. All right, and then let's go to the image part, because now this is how we call. All right, it tells me edit, and let's get paths. You can see it's trying to creating new paths, and cool thing you can do here is to use --watch. Now you can see it's running because now it knows where exactly it goes to pull this image, and that image is available remotely. Cool. Now if you remember the interesting tool I talked about before called Minikube dashboard, we can open this one and see if we got more interesting information over there. So when you click deployments, before it was empty, now we got a deployment here called HB server. Click into it and we'll see that a couple of events happen there, right? And if you click pods, it shows all the pods we just deployed, and it's pretty fresh. Click one of them, it shows you some information about this one, and you can actually SSH into this pod by using that button I just clicked in the top right corner. Since we remember we expose our service at localhost 8000, boom, you got this HTML. So this just means we now already deploy our HTTP application into the cluster, and now it's working. Let's go back to terminal. So keep in mind that we can always run kubectl get all to check current status for our cluster, and now we have 3 pods running. Now I want to show you a interesting feature provided by Kubernetes for you to be able to scale up and down your applications if needed. It's called kubectl scale. You put the deploy name there, and you say I want a -- replicas equals to 5, let's say. So now it's been scaled, and if you get all, you can see it changes the number of running instances from 3 to 5. Accordingly, you can also do replica code 2 if you want. And you can always run get all to check. Now it's trying to terminate 3 instances from those 5 instances. It's also kind of proving that you don't actually tell the details about, hey, Kubernetes, these are the 3 paths that you need to delete. It actually knows how to do it. When you try to run the game, it's not terminating. We'll get to it a little bit of time. But just now, we just demo how do we access this HTTP application from inside the cluster by using Kubernetes dashboard or SSH. But the question now is, how do we make it accessible for entities outside the cluster? The way how we do it in Kubernetes is to deploy another resource provided by Kubernetes called service. And it has different types, but we're going to deploy right now with a type of service called node port. So we do expose. You need to tell it the type of service and node port, which meaning opening up a port in this cluster for outside entities to access. Now you can again check all, and by the way, those 3 paths that are being terminated already gone, and you can see a new service in the type of node port is being created. So now you just need to run Minikube service. And this will starting terminal for your service, and it will actually give you a URL for you to access your pod from your browser. Cool. So this means you already successfully create your own HTTP server and deploy that also to your own Kubernetes cluster. So hope you enjoyed this video, and thank you for watching.